So while we are waiting for our video to be uploaded, okay, so just start the chapter 3. Just need to review this. So let's see. Chapter 3, network automation. Okay. So I think this is where the, what's this? TCP IP and OSI. Class activity, will not be doing that. Okay, communication fundamentals. Okay. So I think they are comparing the communication of humans, between humans and computer. Okay, so humans, they have the message, signal, the medium, the receiver, transmitter, receiver, and the destination. So also in the computer we also have the source, transmitter, receiver, the medium, which is the wires, and then the destination. Okay, the rules, establishment. Okay, so let's see. So in communication we have protocols. So identified, receiver, common language and grammar, speed, timing. Protocols are okay. Before communicating with one another, individuals must use established rules or agreements to govern the conversation. Necessary for effective communication. Okay, so it must be followed in order for the message to be successfully delivered and understood. Okay. Message encoding. What's this? Wait. Common protocols include the requirements. Computer protocols have the encoding, format and encapsulation, message size, timing, and delivery. Let's see. So encoding is process of converting information into another acceptable form for transmission. Okay. So let's see, just need to watch this and we can understand it. I think they are talking. Okay. In computer. Okay. Encoding between hosts must be in appropriate format for the medium. Okay. Converted into bits by sending host. Okay, the destination host receives and decodes the signals in order to interpret the message. Formatting and encapsulation, what is this? Okay, so it is same as in the letter. So formatting and encapsulation. The message is encapsulated to a frame or envelope. Okay. The information is included. Okay, in the envelope. Then the encapsulated letter. Okay, the destination IP address. Like that, the MAC address, I think, then the IP address, destination, source MAC IP address, the data, the source. Let's see. Message size. Okay. Okay, so the message that they send is usually broken into smaller parts of sentence. Let's see. Okay, cannot understand you. Okay, they must be breaked into smaller pieces. Okay, they can understand it. It must be broken into that. Okay. So message timing. Just watch this. Okay. They talk or speak at the same time, so therefore they did not understand each other. Message delivery options. Okay. Must unicast is for one person only. Multicast is for two or more. Broadcast is for all audience. So for unicast, for one PC, for multiple PC or end devices, the broadcast is message for all. Okay. Rules that govern communications. Physical layer. Protocol suites. Protocol suites or suites. So are sets of rules that protocol suites that work together to help solve a problem. Protocol stack of layers. Okay. Each higher level service depending on the function defined on the protocols from the lower levels. Okay. Moving data open. Okay. So on the upper layers, they are focused on the content of the message. Okay. Have the network protocols. Networking protocols define common format set of rules for exchanging messages between devices. We have the HTTP, the TCP, and IP. Okay. The rules of protocols. How and when error access or pass between devices. Okay, they're working with protocols. The role of protocols. Talk na. Let's see. Nasaan na ba tayo? Okay. Protocols. Protocol interaction. Protocols. So communication between web server and web clients is an example of an interaction between several protocols. Let's see. 13 minutes. Okay. So we have the HTTP. Okay, this is a TCP/IP layer. HTTP. So HTTP defines the content formatting of the requests and responses that are exchanged between client and server. Okay. Servers implement this part. The other protocols to govern how messages are transported between the client and server. Okay, the TCP, so it's a transport protocol that manages individual conversations. Okay. Divides HTTP message into smaller pieces called segments. Okay. So in this, I think this is example is from the application layer to network access. Okay, we have the data here. And then the TCP segments it. Okay, the IP is okay for the encapsulation of the segments. So they are now packets, and then the IP is the internet protocol is, so it's assigning them with appropriate addresses, right? Then delivering them to the destination host. Now the internet is so now responsible for taking the packets from IP. Okay. So formatting them to transmitted over the media. So the internet. So in this layer, so they're converting the packets into bits or signals. Okay, the bits. So protocol suites and industry. Okay, in these layers, so this is TCP/IP model or TCP/IP layer model. So the application, and these are okay the protocols for TCP/IP. Okay, the HTTP, the domain name system, the dynamic host configuration protocol, file transfer protocol, TCP is transmission control protocol, UDP is, what is UDP? UDP is datagram protocol. User datagram protocol. ICMP is internet control message protocol. So this is for sending messages between devices. So network access with Ethernet, frame relay, WLAN, so wireless. Development of TCP/IP. Okay, so just a timeline. Protocol suite. We have the DNS, domain name system, translate domain names such as cisco.com into IP address. We also use domain name in the router or host. No, not host. Domain name. So domain name. Host config. So bootstrap. Okay. HCP. Okay, for IP addressing also. For addressing. Okay, so simple mail transfer protocol. Okay. Servers to send email to other servers. Okay. So POP3. Okay, this is for retrieving email from a mail server. Then SMTP is for sending. IMAP is FTP is for transferring file. So this is the protocol for that. And HTTP. Set of rules, exchanging text, graphic image only, World Wide Web. The transport layer, we have UDP and TCP. Process running on one host to send packets of process running on another host. Successful data. Okay. So TCP, we have acknowledge transmissions. With UDP, so there's no acknowledgement. So internet layer, we have IP. Okay, so packages, messages into packets. Also, assigning addresses. For NAT is translate IP addresses from private into public. So routable for internet. ICMP. Okay, for error handling. OSPF. Okay, this is for routing. OSPF. Where did I OSPF for the static dynamic routing. So network access, you have address resolution. Okay, so mapping between IP address and hardware address. Point-to-point protocol. Okay, protocol 4. Encapsulation paths 4. Transmission over serial link. Ethernet. Okay, the interface drivers. 5 minutes. TCP/IP communication. Okay, so they're just this is the data. Okay, more in encapsulation. TCP. Okay, so IP is added to in front. So IP assigns. For what is the TCP? Okay, TCP. So they are converted to bits. So this is just for this is the encapsulation. Open standards. Okay. So they guarantee that no single company products can monopolize the market. Okay, these are the organizations of the ITU, IEEE, ITU, ICANN. Also have internet standards. Okay. These are the organizations. Okay, this is not important. And electronics. Okay, IEEE. Okay, organizations. Benefits of using layered model is okay, the OSI, so application presentation session, transports network data. Okay. So benefits of using a layered model to describe network protocols and operations include assisting in protocol design, because protocols that operate at a specific layer have defined information from that it can act upon and define interface to it. Okay, preventing technology. Okay, fostering competitions, because products from different vendors can work together. So they also have the standards. Okay. So protocol model. This is, I think, this model, and OSS is a reference model. Okay. So TCP/IP model is a protocol model because it describes the functions that occur at each layer of protocols within the TCP. It's also used as a reference model. What? Protocol model and reference. Okay. So in reference model, provides consistency within all types of network protocols and services by describing what has to be done at particular layer, but not prescribing how it should be done. TCP/IP model is a protocol model and at the same time is a reference model. And then IS model is reference model, but also a protocol model for the OSI protocol suite. Okay. The OSI reference model. So we have the application, presentation, provides for common representation transferred between applications, to organize its dialogue and to manage data exchange. And this is for the conversation. Presentation is converting the OS, I think. converting from the language that we use to the language that the computers know. Transport is transferring the data over the network. Network is data link, changing data frames over a common media. So whether it's a PAN, okay, now for physics. So as of now we are in 1:05 AM. So for the TCP protocol model. So the application, transport, internet, and network access. Internet. Please do not throw sausage pizza away. Then application, transport, internet, network access. Best path through network is the internet. So it is like the network best path. Okay, supports transport is supports communication between various devices. Application is the data. Okay. Network access is the medium, the hardware devices. Okay. Okay, now this is the comparison. So for the application is the layer 5 to 7 of OSI model 3 and 4. So it's the same with both model, and for the OSI it's same with the network access. So physical and data link is the same with network access. Identify layers and functions. But let's see. OSI layer, bit transmission. Hirap na. Application, frames between devices, physical. Let's check. Okay. Best path, your internet. So that the application here supports communication across hardware devices. We have network devices. Packet tracer. Let's see. That's it. Too long. Nah, will not be doing this. Oh, we have a challenge. No, we will not. This is implementation. Oh, here. Breaking communication into pieces. Multiplexing is okay. Giving each we need to segment it. We need to break the message into smaller pieces. I like this one. So single communications is a music video. An email message could be sent across a source as one massive uninterrupted string of bits. Okay. So it can be sent with a full file, like that, full message. So if message were actually choosing this method, it would mean that no other device would be able to send or receive message on the same network while this data transfer was in progress. Okay. So other device will pause, will not be able to send data because they are waiting to the massive data to finish. So this will result in significant delays. Okay, we have PDUs. So PDU is just a name for a name for a format from a different layer. Okay. So an application passed down for us. Various protocol information is added at each level. It's known as encapsulation process. So the form that a piece of data takes at any layer is called protocol data units. Okay. So we have here the data. So I think this is the application layer. Okay. PDU is at the application layer. The segment for transport layer. So now the data includes a transport header. Now for the packet, so it's for the network layer PDU. Now we have a network header. So it's I think it is composed of IP address, source and destination. Right? Then the frame. Right? We now have the frame header. So it includes the MAC addresses, the device, and then the bits. So all this information here is converted into a string of binary bits. As an encapsulation example, will not be okay. We already watched this a moment ago. Okay. So just encapsulating data, adding some information, additional information to the data. Okay. The encapsulation is the reverse process of encapsulation. Activity, identify the PDU layer. Okay. So it should be the data, now the segments, the packets, the frames, and bits. Easy. Network addresses. Okay. So source and destination address. Data link layer, source and destination address. Okay, this is for the MAC addresses. Okay, destination address. Either on the same network. Okay, we use IP address for on the same network or remote network, just for delivering IP packet from the origin source. Data link addresses. Okay, we have this is the MAC address, NIC. So the address that is burned in the NIC is the MAC address, media access control address. Okay, the physical address. So the physical address, which is the MAC address. Devices on the same network. Okay. Okay. The network layer and then okay, so we have the network portion. Indicates which network the IP address is a member. The host portion is the remaining part of the address that it displays. Okay, the host portion. For example, we have the network 192.168.1.0. So this is our host address, host portion. So 110. So this is our host portion. It's also based on the subnet mask. Okay. Then source. Okay, data link, Ethernet frame header. So this is for layer 2 address or MAC address. The network layer is for layer 3 address. Devices on the remote network. Okay, the source IP address and destination IP address. Source MAC address. Okay. Source name will be okay. So the data link layer address or MAC address must be addressed first on the router, not on the destination device, literally. So it must be first addressed to the router because it's in the remote network. Okay. But when on the same network, we can directly address the MAC address of our let's call this the destination host. Okay. So we will be having a playlist of our Wireshark activities. Okay. It's a packet sniffer. Okay, let's see. I think we have 6 Wireshark activities. We'll be doing that. As activity. Okay, chapter 3. So summary. I think we are now. So data networks. Okay. So we just learned some reference model, some concepts of the addressing, the IP addressing, the MAC address. So what else? We did not discuss the organizations because we'll just add up to our memory, and we'll just progress our CCNA2. Okay, so just reviewing this, and that's it.